Hey guys, this is the video for classifying and naming angles. As we go through, a lot of this vocabulary should sound familiar. Hopefully it's just a little bit of a review, and there's possibly a couple of new ones for you. Okay, so let's go and start at the beginning. A right angle is anything that is exactly 90 degrees. A lot of times you'll see this symbol, the little box in the corner, that signifies and tells you that it is exactly 90 degrees. If it happens to be something slightly less than or slightly more, that's what we call acute and obtuse angles. An acute angle is anything that measures less than 90 degrees. So you'll see here we got like 18, 45, 33, those are all pretty small. Just note it's anything up to 90. So even this 88 right here, a perfect 90 degrees would be really, really close, but 88 is still smaller than. So I'm gonna make a little note here to myself. It's anything less than my 90 degrees. The opposite then is an obtuse angle for anything bigger than 90 degrees. So again, we have some big ones here like 117, 174, 157. Look how 93 though is really close to this one right here. If it doesn't have that little square, we know it's not exactly 90 degrees. And in this case, when it says 93, it's slightly more than, that's what makes it an obtuse angle. So again, if you want to make a little reminder to yourself, or you could underline it over here, an acute angle is less than, an obtuse angle is something more than my 90 degrees. A straight angle is also one that measures exactly 180. Okay, so we have four names that we probably heard of before. A right angle is exactly 90, an acute angle is less than 90, an obtuse angle is more than 90, and a straight line is also known as a straight angle because it's exactly 180 degrees. The two that may be a little new for us here is reflexive, and then as we name our angles. So a reflexive angle is something more than 180 degrees, but less than 360. So you see how A, B to C right here, this makes an acute angle on the inside. The reflexive angle is my one around the outside. So I'm gonna label that to myself in my notes. It's my outside angle. I want it to be something more than 180 degrees. We just saw in the last example that 180 degrees meant it was a straight line. So in order to be reflexive, I have to go past a straight line and then I keep going. Okay, if it goes more than 360, that's more than a circle though. So I want something more than 180, but less than a full 360 for my circle. Okay. The other thing that may be new is when I name my angle, I have two rays here that come to a common point of Q. In this picture, it's okay to just call this one angle Q. However, you're going to see in some examples, let's say there was an S over here. Now I don't know, is this angle Q or is this angle Q? If there's more than one, then I need to be more specific. So in our notes, they gave us PQR, so that would be P to Q to R, or I can also go R to Q to P, and that would mean the same thing. Typically, they'll put in alphabetical order for you, so I would go P to Q to R, but it is okay to say it the other way as well. Okay. Just know that simply calling an angle Q isn't enough if you have multiple angles within that same picture. A couple more vocab here for you. In measuring and estimating angles, I always have two rays that come together at what's called the vertex. Usually there's a dot. I like to fill it in bigger if I'm about to use my protractor to measure. So just know if you're trying to line up your protractor, it's okay to fill in that vertex and make it a little bit bigger. And then when I measure my angles, you can always denote it by that little bubble as well. So my 90 degrees, I'm gonna go and fix my notes. It was that box from last time, but a lot of times you'll see a little bubble. Just knowing that this inside is 360 and they're not talking about the reflexive part on the outside. We do have one reflexive though, so if you want to star that, this is the new one. The outside of my circle, if something is more than 180, will be noted with that arrow right there. Next we have complementary angles. These are two that add up to 90 degrees. I remember it by changing the C into a 9. See how it makes it look like a 90 degrees right there? So 50 plus 40 is the same as an equal 90 degrees. So my right angle is separated into two different ones, a complementary angle. a supplementary angle are two that add up to 180. I like to change the S into an 8, and then I can put around it so it looks like 180 degrees. That's just my way of remembering. If you have a different way, that's awesome. But in this case, I'm looking for two things that add up to 180. So 130 plus 50 equals 180. All right, now let's actually try a couple examples. Here's a protractor. If you're using a protractor in real life, just be careful. Sometimes they'll have a 0 and a 180 over here. So make sure you know which side of the protractor you're supposed to be using. In my example, I'm starting from the right, 0 to 180 as I read it. In some protractors, you may also have a 0 to 180 on the inside, in which case you could measure from over here and go counterclockwise. Let's start with angle LV to M. Here's L. V is my vertex. M is over here. I'm going to start with L. If I started at 0, I went to 90. This is 100. L is at 110 degrees. But that is the measure of angle J to V to L. I was trying to find L to V to M. So I'm going to keep going. 90, 100, 110, 120, 130, 140. M is at 150. So I know logically this is an acute angle. This is something less than 90 degrees, so I need to subtract them. V is at 150, M is at 150 degrees. My L is at 110 degrees. So the difference between them is 40. Now you may be thinking to yourself, there's an easy way to do this. Couldn't I just count between these two? You betcha, that also works as well. So from L to V to M, I went 10, 20, 30, 40 degrees. Even though on here, right, they both appeared more than 90, I know this is an acute angle, so a logical answer should be something less than 90 degrees. Let's try another one. K to V to N, same thing. So right now, here's K and here's N. My K appears to be at 10, 20, 30, 40, 50, 60. But I know this is a very big angle. This is obtuse. It's supposed to be more than 90. So then I need to find where N is at, which is at 180 degrees. And I'm going to go ahead and subtract the 2. So between them is an acute obtuse angle that's 120 degrees. My K to V to J right here, that was acute. That was too small. So to get all the way to N, I know I needed something bigger. Instead of subtracting, I can also just count between them as well. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I get the exact same answer. Okay, last one. We're trying to find the supplement to J to V to K. So here's J to V to K, which is 60 degrees. So up here, I'm going to look at my picture for supplementary angles. I'm going to draw myself a little visual. So here's J to V to K, which is 60 degrees. The supplement was something we wanted to measure adding up to 180 degrees. So my picture would look something like this. In order to find that exact answer, my straight line of 180 degrees minus 60 would leave me with 120 degrees for my supplement. Just make sure you read the directions carefully on those problems. If it wanted complementary angles, then I would have done 90 minus the 60. But since I wanted supplement and they added up to 180, I knew I needed a big obtuse angle here to complement my 60 degrees.